Hello everybody and welcome to this video series on Postgresql and clustering. And the reason I've put this video together is because some of you will already be familiar with Postgres as a database engine, but when it comes to actually clustering, which means creating multiple replicas of Postgres, it gets quite difficult quite quickly. Mainly because of documentation, mainly because a lot of the tools are sort of command line tools that don't necessarily have a like a tutorial or a GUI or something to help you set them up. So I've actually been through this myself over the course of a number of months, setting up a production cluster at work, and so I wanted to share with you the things that I'd learned and effectively take you through the whole process from right from the beginning, installing Postgres through to setting up the cluster, and then looking at how we set up a high availability system and some failover scenarios. So what we're going to cover is I'm going to give a very brief introduction to PostgreSQL and just cover perhaps just a few of the main benefits of using Postgres, and then we'll look a bit at clustering architecture in general, so a very high level view, learning some terms and just sort of getting a bit of the landscape in our heads so we know what we're working towards. And then there'll be 3 videos on setting up Postgres itself, installing it, which is pretty straightforward, but actually looking at some of the settings that we need to consider right from the beginning to make sure that we can then set up the cluster correctly. And then using something called Barman, which is the backup and recovery manager, and that is to allow us to take backups on a regular interval, store them in a separate place to our main database servers, and that obviously gives us some sort of data redundancy in case our main database servers sort of became unavailable. And then we'll follow that on with some introductions to Rep Manager, which is Replication Manager. And that does 2 jobs really. It's a good way of setting up a new Postgres replica without having to do too much work. And also it's used to control failover scenarios. So if you need to promote a replica into a primary or vice versa, you can do that all from Rep Manager. And as long as that's set up correctly, that all works pretty well and works pretty quickly. But the problem that you'll find with lots of these tools is there are quite a few moving parts, and so very quickly, if you're not careful and you're not very methodical with the way that you approach it, you can end up with something that seems to work, but maybe one scenario works and another one doesn't, or maybe Rep Manager manages to demote a primary but doesn't manage to promote another one to primary. So there's definitely some foot guns there that we need to be careful of. So again, we'll take you through that step by step. And then a high availability configuration is just really an explanation of what we're going to need to set up and the way we're going to have to put something on front of our cluster in order to actually allow those connections to come from our client services and to make sure we're hitting the right database servers. And then some failover scenarios. So, when the rubber hits the road, really, the most important thing is that we know what we're going to do if one of our servers goes down, particularly unexpectedly when the stress levels will be high. We don't necessarily know what we need to do. And then part of that failover will also be how we actually recover from a backup at the end. So that's what we'll split up into a number of videos. This first video will just cover the PostgreSQL introduction, and then we'll have additional videos to cover some of the other parts. Now, in terms of who is this aimed at, I don't particularly expect you to have too much knowledge of Postgres, of SQL generally, of clustering and things like that. But if you have some basics, then you should be able to get by pretty easily. I'm not going to be going into lots of details about every single part of this. So if I'm talking about editing a text file, I'm going to assume you know how to edit a text file in Linux. I'm going to assume that you know the basics of starting and stopping services and what cron is, things like that. So nothing really super complicated, but because I'm not going to explain those things, if you don't know what they mean, you probably need to pause the video, go and have a little look on the internet, and then sort of come back to it. But yeah, no expectation about too much knowledge, but hopefully by the end of it you'll have a fairly good idea of what you're offered in PostgreSQL, particularly in terms of its clustering functionality. So let's go straight into an introduction to the database engine itself. When we talk about Postgres, you'll find it in a lot of forums when people are talking about which database engine or system should I use. Often Postgres is top of everyone's list. People do use like Oracle and SQL Server, Microsoft SQL Server, which are both effectively a licensed products, so they cost money, but they're pretty decent products besides the fact that they cost money. You then have MySQL, which back in the day, before Postgres was popular, MySQL was probably the most popular open source database engine. And then something funny happened and Oracle bought MySQL, and obviously Oracle being Oracle started doing their own things, and what then happened was somebody forked MySQL and created what's now known as MariaDB. So MariaDB and MySQL share a lot of features, but actually they've diverged quite a lot over the last 5 to 10 years, and so they're quite kind of different beasts now. And although I think they're still pretty popular, obviously MySQL, you're kind of treading that line between what you're allowed to use for free and what you need Oracle's permission for. And with MariaDB, there's always going to be that concern that it's kind of a little bit behind MySQL in terms of perhaps features and things like that. So Postgres itself was started as a university project at University of California in Berkeley back in the 90s, and it was effectively a replacement for a database engine they had called Ingress, and hence the name Postgres or Postgres. And then apparently in a sort of a nod to make sure people realize it is a SQL database engine, they decided to chuck that on the end of it and ended up with this awful name. Pronounce it how you like. Most people would just call it Postgres, but some people will say PostgresQL. Some people would just say, PostgreSQL, whatever. So Postgres is probably easiest to remember. And I guess a couple of the main things is it is multi-platform, so it works across pretty much all the platforms that you would normally use anyway. And one of the big things, obviously, for the video that we're doing here is that you get clustering built in. So you out of the box, you can set up clustering. And of course, unlike a licensed product, you're not having to pay the big bucks to get the enterprise editions in order to have clustering functionality. So for any kind of production system, really it's a must. Certainly for your main production systems, you need to have that high availability system. You need that data redundancy, because if you think of all your data being stored on a single database server, there are lots of ways in which that data could get completely lost, whether that's ransomware, a serious hardware failure, or a disk failure. The last thing you want is to be in a position where you don't have any way of sort of restoring that stuff back up. So having a clustering infrastructure is important, having the backups is important, but most important of all of these things is understanding how it works, so that when something does happen, you're straight on it and you know what to do. You're not scrambling around trying to remember how everything works. So that's what we want to get to in here in this video. So why might you use Postgres? Well, we talked about a couple of the things already. It's free and open source. Now, obviously, that doesn't necessarily mean it's always better. We like free stuff. But of course, people do have to work on this, and we want to make sure it's a healthy database engine, not something that gets maintained by 3 people in their spare time who are going to get fed up with it. So what that means is having a different mindset, really. I think if you use open source products, then you should also be willing to support those either directly with sponsorship or even indirectly. If you're paying for consulting from companies like Enterprise Database, who are one of the main supporters of Postgres, then you're effectively paying to maintain the database via that consultancy rather than paying for the product itself. So the fact it's free is pretty cool. Like I say, it's great having clustering for less than $1,000 per node per month, which is what it would cost you with SQL Server. And like I mentioned with MySQL and this idea of sort of a split roadmap, really, it's just a single roadmap. It's had a fairly consistent life, a few features added at different versions. We're now up to, I think, version 15 is the latest stable version. And on Debian, I think 13 is the latest edition that you'll get from the package manager. On Ubuntu it's 14, but they're all fairly similar in terms of the basic functionality. It is very widely used, so there's lots of companies, I mean there's a few there, lots of others, people like Instagram, TripAdvisor, whatever, lots of big people using it, so it's clearly a decent database system. It's usable in production, it performs well. And I guess one of the things that we all like is the sort of configurability, and even though Postgres.conf has about probably 500 parameters in it, you know, most of them will have sensible defaults. There'll be a few that you will always need to set, and the others, they're all there. I mean, I guess it might be a big text file, but at the end of the day they're all in that one place. If you need to go and change a setting, you go into Postgres.conf, put it to whatever you want, and either restart or reload. But then let's be honest, Postgres isn't for everybody. So some customers might say, oh yeah, you can't use Postgres because there's no official vendor, there's nobody who you can go to get that guaranteed support. Now obviously you can get support. Obviously there are companies, a number of very famous companies, who will give you, you know, very high level support with something like Postgres. But again, you'll always get some customer saying, no, that's not acceptable. It's got to be a, you know, a contractual agreement. It's got to be an SLA. It's got to be, you know, a short recovery point objective or whatever. And that may or may not be doable with the various customers that support Postgres. Might not be an issue for most people, but it might for some. Obviously, compatibility is potentially an issue. Now, Postgres has been around long enough that most systems can connect to Postgres as easily as they can connect to Oracle, SQL Server, etc. But it's always possible. There are certain products out there that will not support all databases, and they might be closed source, so they're not necessarily things that you can modify yourself. So there might be some cases where you just can't use Postgres because it's not supported. And in terms of if you're trying to port an existing database schema, which is something I did at the end of last year, you know, not all database systems are the same. So there'll be features that don't exist in one engine that do in another engine, and vice versa. There will be things that are done differently. So stored procs are a big deal in SQL Server, but they're not really the same thing in Postgres, and they're not used anywhere near as much for that reason. There'll be things that you can't just implement in the same way when you port code across. So if you're moving an existing schema from another database engine, there might be a significant amount of work involved there that you might not be prepared to make, which is fine. And then the last one is the need to relearn tooling, operations, any of your automation systems, your management systems, all the rest of it. Again, if you're changing from a different database engine, there's a lot of significant risk there, a lot of potential cost, and we shouldn't be too quick to kind of say, oh, I don't like SQL Server, let's go move to Postgres, because if you don't have the right people to do that, and even if you do, how long is it going to take you? What's going to happen to your existing system? Does it still have to run while the new one's running? How are you going to keep it up to date while the two are running in parallel? There's lots of things here that could end up stinging you. So obviously it's much easier to use Postgres on a completely new application where you get to choose how you do it. So there are definitely some reasons why you wouldn't use Postgres. But I want to finish this video really with a last slide, which is about maybe something that you might consider a bit of a detail, but again, it's something you need to consider when you're looking at Postgres anyway. And that is the way that Postgres has taken a certain approach to avoid locking. Now, locking is an essential part of any ACID compliant database, because what you need to assure your clients is that the data that they're reading is correct at the time that they have read it. What you can't have is somebody reading a row at the same time that a different client, a different connection is changing the contents of that row, because then the first request might end up with half of the old data and half of the new data, and that would be inconsistent, and so that would violate the I of or one of them, the C of ACID consistency. So in order to work around that, all database systems will have locking, and what the locking would usually do is if just a little flag that says I am updating this row, lock. No one else is allowed to even read it because if they read it during the point I'm updating it, they're not going to get a correct read. So I'm going to lock it, I'm going to update it, and then I'm going to unlock it. Now, of course, that's fine in a lot of scenarios, but it potentially means on a busy database, lots of connections are waiting for all of the other connections to finish doing what they're doing and these locks to be released. Bearing in mind that the lock could apply to a page, even a table, if you're doing something significant. So some of these locks can be held for a significant amount of time. And if you've ever seen a deadlock is a scenario where the ordering of the acquisition of locks doesn't line up between two different connections. So in your classic Mexican standoff, connection A has a lock on table 1, but needs a lock on table 2. Connection 2 has got the lock on table 2 already and is waiting for the lock on table 1, but of course they're now at a deadlock because neither of them can get the next lock, which means they can't release the previous lock, and so they're blocking each other. And when that happens, one of the connections will be killed off, and your database client needs the ability to retry that. Now, that's fine. Most database servers will try and reduce locking to a minimum, so obviously they will be clever enough to say if you're doing this sort of operation, you can have a very small lock. Maybe this type of operation requires a page lock, or maybe even a whole table lock. But what it does mean is at volume, it can very quickly become poorly performing. And so what Postgres have done is they've worked around this by having a concept of data tuples is kind of how they store their sort of changes, their log data. But the idea of immutable data tuples. So you don't change a row, you create a new version of it, and then you tell the database to look at the new version and not the old version. Now, why is that important? Well, what it allows you to do is it allows a connection that comes in to read some data to point to an immutable row of data and read a completely consistent row, even if that row is in the process of being updated by another connection. The row it's looking at is a data tuple based on the previous version. The new one is the update is creating a new copy of it with the various updated data in it. Then it's going to replace it. So those two things are happening in parallel, removing the need for a lock. Now, that's great. It increases performance significantly for highly parallel database operations. The problem then happens is you've got all of these. How do you know when these dead rows are not needed anymore? And so what happens is these tuples get marked as dead, and then eventually during this process that they call vacuuming, which is set up automatically, but you'll need to configure it yourself. This vacuuming will go through and it will try and release these dead tuples and basically give them back to the system to say you can reuse this space, this memory, because we don't need it anymore. Now, if you've got a large database, or certainly large tables in a database, then this vacuuming can have a significant impact. But even worse, it is possible to have a database where the vacuuming cannot happen quickly enough to stop the number of dead tuples increasing. And of course, if it increases, eventually it will run out of memory and you'll have a big problem, or it will have to invoke a significant full database vacuum, which will basically lock everything and stop everything else from working. The reason I mention it is it's one of those things where it's not a problem until it becomes a problem, but once it becomes a problem, it's going to be a big problem. So you need to kind of know in advance that if you've got a system of significant size, this is something you're going to have to think about up front. And one of the ways in which you can configure it, for example, is you can say that rather than waiting for the default of, I think it's 10% of dead tuples before they get eligible for vacuuming, you can say, well, on a large table, 10% is far too big a number, so on a specific table I'm going to reduce that to maybe 2%, whereas on the small tables I can leave it at the default. And what that's going to involve then is much more frequent vacuuming of the large table, which means we're not going to get to the state where we're suddenly trying to vacuum up, you know, hundreds of megs of data or whatever. So I did want to mention that just now because it's not an issue that you'll find in other database engines, or certainly not the main ones, but it's something quite significant which it will affect your design. It won't affect clustering particularly, but it's just something that I thought you should know. So that's the end of our kind of introduction to Postgres. Why Postgres? What are the benefits? What are the downsides of using it? In the next video we're going to be looking at clustering, just like I say, at a very high level, get the idea of what clustering is, what it looks like in Postgres, and what effectively we're going to set out to build. So I'll hopefully see you again in the next video.